Yeah, so good again. So today we are just going to be looking further into you know, the structural drawing and detailing then curtailment of bars. Then we are now going to be going into this bar bending schedule. So this definitely is derived from the structural drawing because you can't get the bar bending schedule without getting your structural drawing first and the detailing. So now let's get right into it. So let me first point out to you the key columns here. This is your serial number, just numbers. Then this is the location of your of where your bar is going to be. So in this case, we have bin B because we are designing for bin B in this place. Then this bar mark is just basically tags. So we just name them O1 or tag them O1, O2, O3, and so on. So this description is just the description of the bar size and the type, either Y, whatever, or R, which is high yield and low yield steel. And then this shape is the shape of your reinforcement, your bars. So in this case, this one is a straight line, but let's leave that for later. Then the length, what is the length of your bar? Then this total number of bars is how many bars are required or are needed in the beam that we are discussing. Then this is the total length, which is just you multiplying this and this. That will give you your total length. So that's that. So I hope you understand. Then let's now go right into this first one, O1. As I mentioned earlier, I said it is just tag. It has nothing to do with type or whatever. But then they use these tags mainly to denote or to distinguish between shapes of bars. So since this one is just a straight line, so we are just going to call it O1. Then this one is a U-shaped bar. We are going to call it O2. Then this one are links, so let's call that O3. Then this, if you notice right, this straight this thing. So since we are taking it from bin B, and then our bin B from here is this. Our bin B is this. Oh, I should have not cut this earlier. But let me bring out another image. I think this is it. Yep. So we are going to be using this instead. Maybe I'll drop it here. So we are using this. So since this is our bin B, and that straight line comes from this straight bar here. That's where the straight line comes from. This straight line that you can see here. So this straight line. Then to now get the length of the bar to right here, we are just going to, from the curtailment this thing that we did the last time. So since we've curtailed it like cuts, so this part is just you would minus or subtract the 6 meter length of the distance minus 0 point 0 points, was it 0.48, twice. You are doing it twice, so minus 0.48 minus 0.48. So whatever it gives you is your bar length, and that's what you have here to be 5.04. That's the length of our bar. So since it is the one at the middle, how many of this bar do we need really? So we are going to be needing at least 2 of it. Oh, not two basically. Not two. It is actually 6. because two on this layer here, so two on this layer, and then two on this place, or four, sorry, it is four on this place, four on this place on the topmost layer, then two on the second layer here. So that's why we are going to have six of those bars, and that is how we have six on this number of bars. Then the total length of the bar is just basically this multiplied by this to give you this. So then this U bar is none but this U-shaped bar that we have throughout the beam, which is this, yes, this, from here to this place. And then how many of these bars do we need in the design or in the arrangement? We need actually six also, or is it? Oh yes, we are having eight, because we are taking this also into consideration. It's these bars are six, then plus the two, because we have two of these bars over here at the top bars, so we are adding them, making eight. So you don't have to tag them differently, so we are making them into one tag, so it can just be easily identified as same bars. So that's what we've just done here. Then what is the length? So from our curtailment knowledge, the anchorage length is going to be considered, because you are not just going to you are not just going to stop your bars at the center of the supporting beam, or maybe column in this case. So you are going to extend it a bit further for adequate anchorage. And then there's something called anchorage length, and it is always gotten by multiplying 12 by the diameter of the bar, which in this case the diameter of our bar is 25 multiplied by 12. It gives us, I think, 300. So 300 is our anchoring length, and this is it. And then this this 6.3 is gotten from nothing else than, so I'll show you this now. So remember I said in our previous video that the effective length of beam starts from the center of one side to the center of the other side. So the effective length of our beam, since our bar is going to extend it, like it's going to go further beyond the effective depth or length, I mean. So we are just going to assume, or take, we are not just assuming, we are going to take 150 mm to this side and 150 mm also to this side. That's making 300 mm. That's 0.3. So that is how we added 0.3 and extended that 6 meter bar, making it 6.3 meter, plus then this anchorage length that we have to be 0.3. And we have two of these anchorages, one on this side, one on this side. Then adding everything together would give you the length of our bar. Then how many of those bars do we need? We need 8 of this, and that gives us, and then the total length gives us 55.2. So that's that. Then our links, or our stirrups, we have it to extend from it actually extends from around 10 cm after the face of the beam, or the support of the beam, because we can't take link into the column. So we are just going to give it at least 10 cm allowance. Then from here to this place, that is where our links are going to be placed or arranged. Then according to my calculation, I got it to be 20. We actually need 20 of those links to fit in that place, to fit in this area of space. I'm sure you can get how to calculate that. I don't have time to be explaining that now. So also, there's something called anchorage here too, and this anchorage here is usually 40 multiplied by the diameter of our bar, which in this case is y20 also. Yeah, we are using y20. Oh, sorry, I mean y10. Y10. Then our anchorage length here would be 4 multiplied by the diameter of the bar, which is 10. 4 times 10 is 40. So our anchorage is 40 mm. So that's what we have it here. Then this also, no, you can just find a way to get it on, because you are going to take your cover out of the beam, and no, just these are just intuitive things that you can get yourself. Take your beam width, take out 2 covers from it, because everybody have their own unique covers. So just take your own cover out of your beam and get the length of your link and the depth too, and then just add these 2 up, because we have 2 anchorages here. So we have 40 on the side, 40 on the side. Then add it with this one, with this length. Add it also with this, add it also with this, and add it also with this. So yeah, I got 1.94 meter after adding everything together. So then we need 20 of these bars, as I said earlier. Then the total length of the reinforcements that is required for the link is now 38.8 meter for the whole span. Throughout the whole span, we need 38.8 meter length bar for it. So going to slabs. Yes, so we are going to our slab now. Our slab. Yeah, we don't really have anything complicated or anything really hard in it. So our bar size here, from the description or under the description, our bar size is 16. That's why 16. Then this firstly is gotten from this particular area. Actually, let me just take it from this plan. So this length from here, I'm coming from here to this place, is what we have to be 5.6. How did we get it? We got it from, I explained that last time, so that we need the maximum area of bars at the center of slab or beam, because that's where the maximum bending moment really is effective. Then other parts or other extension, we have less of bending moments. So we are just to curtail it, or by reducing or totally removing the bars. But in our case here, we are just reducing it by half. So we are taking half of what we have here on this side, extending it to the support. So the length, how do we get the length here? Since we know the span of our slab to be 9 meters, so we are going to remove 1.8 from our previous video that I did. I think it's not 0.2. Yes, 0.2. Yeah, that's it. 0.2 distance from the center of the support to this side. To this side. So just remove the amount of length that you need, subtract it from it. Do the same here too. So you have your length. Yeah, you have the total length of the bar that you need for this middle span, for the center span, which is from here to here. So this is what we got here to be 5.6. So 5.6, then calculating how many of those bars we need throughout that span, like throughout from this place. I don't know if I mentioned this. I said this this diagram, this plan diagram is not to scale. So I'm just using this to explain that. So how many of these bars is required for this area from here to this, just to this edge here, because we are not going to use it at the edge but just before it, because we are going to take out cover, of course. So calculate how many bars you need for it to be designed. These are just the basic things we did in, I think it's now 3 whatever, I don't know, structural drawing. So then this one is the complete length. Remember we said this length, this whole span is 9 meter. Then we're not just going to take that 9 meter, we're also going to extend a little bit further into the support here. Then just these two, just before the center line. Yeah, so as you can see, this didn't meet into the center of the beam, or it didn't touch the center, while this extends almost or just after the effective span, meaning the center of the beam. So that is what that one is. So let's continue. So that is how we deduced 9.2, because the span of this place from here to here is 9 in total. Then well, we could have used that 9, because since we are taking out of this one, yes, you can use 9, you can use your own length. So since we are taking a little bit out of this space here, I mean between the center of the beam and this face, and we are shifting it a little bit further here, so you can just use 9. I would erase this, so that's a mistake from my end. So you can use that 9 like that. So then the total area is this multiplied by the number of bars you actually need to complete it, to give you your total length. While then this is the distribution bars, which are these dots here. So this also is going to be catered for and done. Same goes with this too. Okay, and then this one here is the I don't know what to call it, like hook to hold it at the support. But there are some cases where we have this stuff here as this, in most cases. So this is how bars typically look. And so this one here for this case is something like this, and we are going to calculate or know how many of these bars we also need there, and get the length also. So from here, from our beam depth, we can find the length of this. So in this case, our beam depth is 750. So since it is 750, we are just taking 430 out of it, and the length so the length is from this place. Remember I said here it is this actual top bar that we have here is going to extend just 10% of our span, which is 900 there. Oh, I mean, sorry, 9 meter, which is 9,000 mm. So 10% of 9 meter is 0.9 meter, and that is what we have here. So since this also extends a little bit further, are going to add some distance to it. So that is how we got 0.96. We are adding just 60 to it, and that's what we have. That's how we got there. So we are going to add the two lengths together to give you your length of the bar. Then this is the length of the distance we need. Then we have how many number of bars? 45, according to my calculation, because this, I believe, this slab there, like from here to here, is of course going to be the same length, or going to span the same length as the beam, which is beam B. So our beam here from here is 6 meters, so it is 6 meters. So that's what I mean by we are going to use this 6 meter, that is 6 meters to derive how many bars we need for it to that would contain or be arranged in this area, in that area of 6 meter. So that's that. Then I think I'll have to import other things. Let me bring it on again. Okay. So we are done with that. Then the other span, the span BC, we just basically do the same thing, and I believe you've gotten your own drawing too. So this bar here is what you have to be 2.75, oh sorry, 2.7, 2.7 meter. That's the length of the bar. Then multiply by the then this is the number of bars required for the area of. Then this is the total length, which you get by multiplying this by this. Then this one also is the longer. Yeah, this is the distribution bar of the span BC, and then this is the main bar, which I explained earlier, I think in the last video, that the main bars for bottom reinforcements is always at the bottom, which you would always see as BB, which you also always see as BB. You always see things like this on structural designs. BB means bottom. While BT means bottom top, which is bottom top, which are all these ones. This is a bottom top bar, while this one is a bottom bar, and this is the main bar for here, and this is the distribution bar. But for the top bars, or for the compression bars, this one is a tension bar, because we are dealing with something like a cantilever here, which is actually a cantilever because it's an overhanging beam or slab. So this here is a top bar, TT, which is the main bar for this, because this one is the one that there is external, while this one is the one distributing the load or the stress throughout this main bar here. So this is the distribution bar for this one. This is called TB, top bottom, because this is top, this is top bottom. So that is how that one is. So let's go back to the scheduling again. So this one here is our main bar, and this is our distribution bar, and that's how that's why I explained what it is there to you. So I hope with this, I just hope this video helps. And if you don't understand anything, you can just WhatsApp me, get me on, because I know that there will be you'll have a lot of issues calculating. No, just message me, because and I'm sure that some people will get it without having problem. But if you don't get it, you can just say I would reply you.